Welcome to EDU World Space.
In this question, we have a double column C is pin connected along the elliptical track, and then another side is pinned along the rod AB. We are given the angular velocity of AB here, okay, which is e to the 0.5 t square. We are also given the radial distance of the collar at any theta. Okay, so in this question, we are given we are asked to find the radial and transverse components of velocity and acceleration of c at t equals to 1 second. So since we need to, so based on that, based on what we are asked to find, and we look at our radial function, there is a theta. We need to actually calculate the theta at t equals to 1 second, and we will be using Simpson's rule to determine that. Okay. So, based on this, based on the requirements of the question, we'll first find theta. Okay, so solution. Okay, so Simpson's rule states that given a definite integral a to b fx dx is equal to delta x over 3 f a plus 4 times of f a plus delta x plus 2 times f of a plus 2 delta x, okay, until you reach f of b, okay, and delta x is equal to b minus a over n, and then the 4 and 2 just alternate, the factor 4 and 2 just alternate, okay, so it allows us to find approximate the value of the definite integral. Okay, so in our case, the angle theta at t equals to 1 second is equal to 0 to 1 theta dot dt. Okay, so this is 0 to 1 e to the 0.5 t square dt. Okay, so our n is 50, so our delta t is 1 over 50, which is 0.02. Okay, and what I've done over here is to show the table of the numbers from t equals to 0 to 1 in steps of 0.02, and then including the factor, and then multiply the function with the factor. And then if you sum the last column on both tables, okay, then multiply by delta t over 3, right? So Simpson's rule would say that theta t equals to 1 second is equal to delta t okay, so this is delta t over 3, and then you do the sum, okay, so f0 plus 4 times f of 0.02 plus 2 times f of 0.04 plus dot 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 until f1, okay, where ft is 0 exponential 0.5 t square, okay, and you calculate this, you get 1.195 radians, and this is 68.5 degrees, okay. Okay, so this is one of the answer that we need to find using Simpson's rule. Okay, so just check the table. You can just use Excel to calculate, to generate all these numbers, and then you just sum the last column and you get 1.195 radians, okay, sum and multiply by delta t over 3, okay. Right, so now we can get back to do some calculations. Okay, so before that, let us recall the formula. So VR, this is the radial component of the velocity. This is r dot. Okay, and then our transverse components is v theta is r theta dot, and then AR is the radial components of the acceleration is r double dot minus r theta dot square, and then A theta is r theta double dot plus 2r dot theta dot. Okay, so we need to differentiate r respect to time and also theta with respect to time. Okay, so we have so we first find at t equals to 1 second. Okay, theta dot is equal to e 0.5 t square at t equals to 1. So we have e to the 0.5. This is 1.649 radians per second. Okay, theta double dot is 2t times 0.5 e to the 0.5 t square at t equals to 1 is e to the 0.5. This is 1.649 radians per second square. Okay, and then we have r equals to 0.4 sine theta plus 0.2, and then theta is 68.5 degrees. So we calculate this to be 0.5721 meters, and then r dot is 0.4 cosine theta dot. Okay, and then at t equals to 1 second, this is equal to 0.4 cosine 68.5 degrees multiplied by theta dot 1.649, and you get 0.2421 meters per second. Then r double dot is equal to minus 0.4 sine theta dot square plus 0.4 cosine theta double dot. Okay, so you have minus 0.4 sine 68.5 degrees 1.649 square plus 0.4 cosine 68.5 degrees times 1.649. Okay, calculate this, you get negative 0.7697 meters per second square. Okay, now we are ready to calculate the various answers. So the radial components of velocity is r dot. So this is 0.242 meters per second. V theta is r theta dot. So this is 0.5721 times 1.649, and you get 0.943 meters per second. Okay. Then the radial components of the acceleration is r double dot minus r theta dot square negative 0.7697 minus 0.5721 times 1.649 square, you get negative 2.33 meters per second square. And then the transverse components of the acceleration is r theta double dot plus 2r dot theta dot is equal to 0.5721 1.649 plus 2 times 0.2421 times 1.649. Okay, you calculate this, you get 1.74 meters per second squared. Okay, so here are the answers. Radial components of velocity, transverse components of the velocity, radial components of the acceleration, transverse components of the acceleration. Okay, and that's all for this question.